linear motion, type 6, overtaking and greatest lead. So in this question, we're looking at 2003, question 1b, where we have a man running at a constant speed to try and catch up with a bus. At the instant the man is 40 metres from the bus, it begins to accelerate uniformly from rest away from him. So when we have two objects trying to catch up and overtake with each other, if they start in the same position, we say on the point of meeting or colliding or overtaking, we would have the distance travelled by both to be the same. But because the bus is already ahead of the man, then we have a slightly different situation. So if we draw a little diagram to represent this, we have the man is running to try and catch up with the bus. We have the bus is 40 metres away from. So in other words, we have 40 metres between the man and the bus before the bus starts to move away. And then the bus will accelerate away from the man. And at a certain point, they will catch up. So I would say catch up or overtake. Now in reality here, the man's not going to be able to overtake the bus because the bus is accelerating away. So if we say that the distance travelled by the man is S1 and the distance travelled by the bus is S2, then our relationship here would be the gap between them is represented by D. Then we would have S1 would be equal to D plus S2. So this is what we're going to use to solve our question. So the first thing we want to find is the constant speed of the man. So we're going to need to write down what do we know about the man and what do we know about the bus, and then what do we know about when they just catch up with each other. So for the man, we can see that he is running at a constant speed, which we don't know, is what we're trying to find. So we'll call that U. We know that he is running at a constant speed, which means he is not accelerating, so his acceleration is 0. And we know that the man just catches the bus 20 seconds later. So the time he spends running is 20 seconds just to catch up with the bus. If we're looking at the bus, well, the bus starts from rest, so therefore the initial velocity is 0 metres per second. He accelerates away from the man, but we don't know what the acceleration is, so we'll call that A, and it's accelerating uniformly. And again, of course, the time when the man just catches up with the bus is 20 seconds. Now we don't know what the final velocity is just before he catches up. So if we look at setting up an equation for V, the final velocity, well, we have V is equal to U plus AT. So therefore we'll have V is equal to U, which is 0, plus AT, so that's going to be 20A. So that would be V2. Now the initial velocity, final velocity of the man is still going to be the same because obviously he's moving at a constant velocity. So those two are the same. Now the key to this is when it's just catching up. So if he just catches the bus, well, that implies that at that instant when he's just catching the bus, that the velocities are the same. So therefore we would say that 20A must equal U, or U is equal to 20A. So therefore A can be written as U over 20. Now we're going to use that to try and find the constant speed of the man, which is U. So therefore that's why I'm writing A in terms of U rather than U in terms of A, because I want to find U at the end. But you could of course find A first and then sub back in and find U. I mean, it doesn't make a difference really, whichever you prefer. So we have to use the second piece of information that we know about this when they just catch up. And if I go back up to the diagram, That's the fact that S1 is equal to D plus S2. So we now want to do is set up an equation for S1 and S2. So for the man, again, well, what I can say is if S is equal to UT plus a half AT squared, then we said the distance travelled by the man was S1. Well, initial velocity is U times T, and U times T is 20U, and a half AT squared is going to be 0. The bus then, if we're looking at, again, S equals UT plus a half AT squared, well, we said the distance travelled by the bus was going to be represented by S2. So we have U is 0 in this case, so we have a half times A times T squared. So we get S2 is equal to 200A. But we've said that A is equal to U over 20. So therefore we have 200 times U over 20. So in other words, S2 is equal to 10U. So if we really use our relationship then, but we have S1 is equal to D plus S2. Well, S1 we've said is 20U. D, the distance between them was 40, plus S2 is equal to 10U, and therefore that gives us 10U is equal to 40. In other words, U is equal to 4 meters per second. So we've now found the velocity at which the man is travelling at. And of course then we could also work out what A is by subbing back in. And I know that A is equal to U over 20. So 4 divided by 20 for A would be equal to 0.2 meters per second squared. So not asked for in this part of the question, but I've worked it out just to show you. So if we go back up to the question, look at part 2, then it says, if the constant speed of the man had been instead 3 meters per second, show that the closest he gets to the bus is 17.5 meters. So essentially we saw there that if he just catches the bus, he must be running with the speed of 4 meters per second. So if he's running at a constant speed of 3 meters per second, he's not going to catch the bus. But at a certain point, what will happen is you're going to end up with the greatest lead, where the bus and the man are just moving away from each other and the gap isn't changing. So when that gap isn't changing, again, their velocities must be the same. So for the greatest lead, we'll have V1 equals V2. Okay, so let's set this up. So again, we'll look at, for the greatest lead, V1 must equal V2. So that's our way to solving. And of course, then we'll have to work out the gap between them in a minute after we have worked out our distances. So we'll look at the man and set up our equation, and we'll look at the bus and set up our equation. So again, for the man has a speed this time of 3 meters per second. So our time isn't going to be 20 seconds anymore. We don't know what the time is. So we're just going to let our time be t seconds. And he's moving at a constant speed. So again, he has no acceleration. If we're looking at the bus again is still starting from rest. And the acceleration is 0.2 meters per second squared. And again, we don't know at what time this is occurring. And we'll call our velocity V2, where of course our final velocity of the man is U, because obviously he's moving at a constant velocity. There is no change in velocity. So again, if we look at setting up an equation in terms of velocity for the bus, our V is equal to U plus AT. So we will have V2 is equal to U, which is 0, plus AT, which is 0.2t. And at the greatest lead, V1 will equal V2. So we'll end up with U, which is 3 meters per second, is equal to 0.2 t. So in other words, the time at which they have the greatest lead will be 15 seconds. So we need to know, well, how far has the bus travelled in that time, and how far has the man travelled in that time? So again, for the man, if we're looking at S is equal to ut plus a half at squared, well, our u is 3. The time we've just worked out is 15, and of course he has no acceleration, so it's just u times t, gives us 45 meters. The bus, again using S equals ut plus a half at squared, well, S2 then would be equal to, again, no initial velocity, so just a half at squared here. And the distance the bus travels is 22.5 meters. So of course we have to take into account that there was actually 40 meters between the two at the start as well. So therefore for the greatest lead, it's going to be D is equal to, well, S1 plus 40, because the man was 40 meters away from the bus to begin with, minus the distance travelled by the bus. So therefore that will be 45 plus a gap of 40. Sorry, I've said that the wrong way around. And just undo that. And change, that shouldn't be S1 there. And S2, it should be the other way around. So it should be the distance travelled by the bus plus the gap between the bus minus the distance travelled by the man will give us then the gap between the two, because the bus was already 40 metres ahead of the man to begin with. So we have S2, which is 22.5 plus 40 minus S1, which is 45 metres, and therefore the greatest lead between them will be 17.5 metres. And if I go back to the start of the question, it said if the constant speed of the man had instead been 3 metres per second, show that the closest he gets to the bus is 17.5 metres. So therefore that is what we have just shown. So we're happy with that. Okay, so let's have a look at the mark. So for getting our acceleration in terms of u, we were getting 5 marks. For getting our S1 is equal to 40 plus S2, we were getting 5 marks. And for getting our initial velocity, and we didn't have to get the acceleration, but obviously it's required for the second part of the question, we were getting 5 marks. So the 5 marks there was going for U, but A obviously was part of the marks for the second part of the question. So for the second part of the question, there was 15 marks going for this. So again, we had 5 for getting our time, 5 for setting up your 2 equations for S1 and S2, and 5 for getting D is equal to 17.5 metres. Okay, now you can of course use differentiation in this question as an alternative solution, looking at the closest or the least amount of distance. But sometimes I think sticking to what you know best is easier. But of course, if some of you have done it by differentiation, that's fine too, as long as you're getting out the correct solution.